Thank you, James. Welcome, everybody. It's so exciting to see you all here. This is our biggest event yet. When we started, it was kind of hard to find causal AI enthusiasts. Now we have to, have 2 overflow rooms. So it's been quite a journey here, and the community is going from strength to strength. And a lot is happening in AI. Over the last 2 years, it's been pretty exciting to watch the pace of change. And so today we're very excited to show you how us at Causal Lens, we've been embracing all these latest developments at what is the fastest moving field in the history of humanity. And it's pretty exciting, I think, to be here in an iconic place where science was created and be a small part of what will be the most transformative technology of our time. What if you could create a decision-making agent that can help you make some of the most important decisions in your company at no cost? This is the question we'll try to answer today. How can we achieve this? And how can we unlock a future in which we can all have a decision-making agent at almost no cost, helping us make the most important decisions in our business or in government or in society at large? Before we answer that question, I want to show you or tell you a few stories about the tremendous value that technology like this would create. And I'm going to tell you 2 real examples of this. The first one is in healthcare/government policy decision making. So this is with a G7 government, a government agency. They wanted to understand the causal effect of a policy decision on availability of drugs. And they wanted to answer this question at a very granular level. They wanted to know a pharmacy in this small village, in this particular part of the country, what would happen to the availability of these certain types of drugs if they were to change this policy, right? To answer this question, you have 2 options, I guess, or 3 options. One is you could just do it by gut feel and read a lot of opinions, which will be suboptimal to say the least, given our audience here would agree. The second would be to spend 3 to 5 years building granular models with humans, which will be extremely expensive and maybe hard to justify, as well as too slow for decision making. And the third option would be to find a way to automate and build very granular models that could help you answer this question. And that's exactly what we did with this partner. We enabled them to create granular models and be able to answer the question of what is the causal impact of change of this policy for every part of the country, for every single pharmacy, for every single drug. This requires thousands and thousands and thousands of causal models. And it's very, very hard to do by human approaches. The other thing they wanted to know is they wanted to actually evaluate all the potential counterfactuals. They wanted to understand what is the optimal change in the policy, right? And as you guys would know in this room, this is a very causal question. It's very, very hard to answer with kind of predictive type of technologies. And so that's just a small example of the tremendous value one can create if we have this ability to automate. But also, automation is not enough. We need automation that we can trust, right? Only then we'll be able to incorporate this in our decision making. Let me give you another example. This is not quite the factory of our partner, but it looks similar like that. And they're making cakes. It's a pretty yummy cake. But every morning, before they start the manufacturing line, they have to run the line and tweak the parameters of the process until they get the perfect consistency of cake. And that actually wastes a couple of $1 million of cake every morning. Just goes to the bin because humans you're tuning the parameters, and obviously every morning it's slightly different parameters. We have slightly different humidity, slightly different temperature, slightly different environment, and so every day you need slightly different settings. So every day you lose a couple of $1 million worth of cake while tuning. And so now imagine if you had an AI agent that before you came into the office, while you're having your morning coffee, it was able to analyze the data and tell you, hey, here are the optimal settings. Just start the manufacturing process with the optimal settings. That will result in a better start of the morning, but more importantly, less waste of cake, right? And so I gave you those two examples just to motivate the reason why we want to have AI agents helping us make better decisions in all walks of life. And these two are real examples, and they both require a high degree of automation because it requires building usually a lot of models, a lot of it requires sifting through tons of data, but they also require trust. We cannot have just automation. We need to have full trust. Otherwise, we can have automation that no one uses, right? So the talk today is about how can we achieve both? How can we achieve automation so we can all have AI agents, but also in a way that we actually trust them. And what we will see is that causal AI is one of the key ingredients in bringing trust to the table. And so if you were sitting there and thinking, you know what, LLMs are really great, I'll just get my LLM to do this automation part. You would be right, it can do the automation part, but you will be leaving the trust on the table. So you'll have things that are very fast to build, but no one uses, right? And actually, there was a cool study that did just that. It was trying to understand how trustworthy are the LLMs today in 2024. This is a recent paper. So what they did is they took 400, I believe, or 411 questions. All of these questions relied on a lot of quantitative data, right? Time series and tabular. They took all of the best LLMs, open source, closed source, you name it, everything was there. And they wanted to understand how good are these LLMs out of the box in helping us make better decisions. What they concluded was that although they were fast and automated, they were not very good. And they would only work in like a third of the cases. And so, of course, when you have something that works in a third of cases, you will assume that for your particular example, it may not work, so you're not going to use it. The paper went further to state that these LLMs are not very good at causal reasoning. And so, not good at causal reasoning, not good at answering quantitative questions in a reliable way. But as you will see in a minute, LLMs are going to be really great and are going to be part of the future, and we are fully embracing them. So you'll see how. So that's one way to do it. The other way to do it is to say, let's look at the tools we have in our environment. Like let's maybe look at Tableau, or let's look at a data science platform. And those things can be useful, but if you just rely, say, on Tableau or something like that, all you're doing is you're building dashboards that tell you what happened in the past. You're not really trying to make decisions about the future. You're still baked to gut feel effectively. You're saying, oh, let me visualize the past, and then let have a human kind of figure it out from there. So you haven't really moved away from the gut feel decision making. If you're lucky, fortunate enough to have a data science team and a data science platform, well, they could do that. They could help you make quantitative decisions. But there's two problems with that. One is, you need to have a data science team, and usually you have more questions than humans helping you answer them. And the second problem is, most people, most platforms, and most data scientists can only build predictive models. And predictive models are not quite suitable for decision making. As you guys would know, in this room, we're all causality people here, we know that we need to answer the what if question, we need to answer the counterfactual question, we need to be able to figure out the optimal next thing to do in order to achieve a goal. And so now we have an opportunity to enter a new world, a new wave of change, which is agentic systems that can help us answer causal questions. And we can do that, so for the first time, we can have a world where we can automatically solve problems and we can have it in a trusted way. And so before you think, so that does mean, now once we have the agents, does that mean we don't need the humans or the data scientists? Well, the answer is really no, because we have exponentially growing data and linear growth of human data scientists and engineers. And so this gap is growing by the day. And we actually want the humans to be solving the problems that the agents can't solve. Because there's always going to be really, really hard problems that agents cannot solve. And that's where we need the human data scientists to focus on. And we also need the human data scientists to verify that the agents are doing a good job. And we'll see that in a second. And so the opportunity here really is not, let's find an automation to not need data scientists. In fact, is quite the opposite. It's about, can we empower data scientists to help us with this exponentially growing data that we currently just cannot make sense of? When I had a conversation with Judea Pearl, and I've met him a few times now, and he always comes back to this one point. He's like, even if I had $100 million, I still could not find 100 causal scientists. And that always stuck with me, that's kind of extraordinary that even with $100 million, you could not hire 100 causal scientists. You would need to actually figure out a way to create or train causal scientists. So he said, Judea told me, like, Darko, your job is to create as many causal scientists as you possibly can. And we have obviously done that in our team, but obviously we realize that no matter how fast we grow as a company, we're against an exponential curve of data. So we thought that we need to find a better way to scale the amount of causal data scientists. And so that's exactly what I wanted to share with you today, is that we have created the first agentic AI data scientist that understands causality. And we've been able to do this by combining three types of technologies. One is taking what LLMs are very good at, and that is ability to write code, and that's one of the big disruptions they're creating, and they're extremely good at that. They're language models, code is language, great fit. But as we identified earlier, they can write all sorts of crazy code, right? And that means we lose the trust. So what if there was a way to have automation but also have trust? And that's where the intersection of causal AI and data and machine learning pipeline automation comes in. So as you guys know, causal AI is extremely interpretable. It can reason like humans through cause and effect. It allows us to really understand how the AI is working. We also need to acknowledge that modeling is a small percentage of the entire flow, going from raw data to a better decision. And so that's where the machine learning pipeline automation is extremely valuable. We want to be able to find a way to automate some of the repetitive, slow tasks, like figuring out what data set is useful, or figuring out how to clean a data set, or figuring out how to engineer features. figuring out how to build a web application more effectively. All these things are extremely important part of creating a decision-making workflow, and it's extremely important that we automate them in a trusted way. So today we're launching Kaya, which is an AI agent that lives in the intersection of these three technologies. And it's able to take us from raw data all the way to a web application, essentially creating the assets for a decision-making agent. So what Kaya creates is effectively the artifacts for your own decision-making agents. And it does this automatically while ensuring trust, while ensuring the end user is in the loop, while ensuring the data scientist is in the loop. And so for the first time, we no longer have automation versus trust. We can have both. We can have automation and trust. And the way we've trained Kaya is on what we call the treasure trove, is the unique assets that Causalens has. And those come in a couple of shapes. One is the biggest ecosystem of causal AI package, unified ecosystem of causal AI packages in the world. Everything plays together, everything is unified. There's no code base like that. We also have pretty cool technologies that we've developed, from a web application framework to pipeline automation technologies, all sorts of really cool things that we've been able to give to Kaya to learn how to build decision-making agents. We also have solved thousands of problems with, on both real-world data and public data set that helped us, which helps Kaya learn how to automate some of the the less glamorous parts of data science, like data cleaning and feature engineering and things like that. So Kaya is trained on the biggest causal AI ecosystem in the world, a unified ecosystem, thousands of real-world examples about solving real-world problems, as well as really cool code around automation of AI pipelines. And so we've brought this all together, and you guys will have the opportunity to see this in action right now. We have not shown this before. We're launching it today, and it will allow you to see, how the future of decision making looks like. So, do you guys want to see it? Excellent. So, we're going to solve a manufacturing downtime use case, like the one we saw with the cakes, right? And so we're saying, hey, I have this data set of manufacturing data, and I'm trying to reduce the downtime. I'm trying to find the root causes of failure in this manufacturing line. And so what this will do is it will ask you, okay, what are you trying to optimize? Well, I'm trying to optimize the quality. And we'll actually build an entire plan of how to solve this. And so here's the plan. It will clean some data, it will figure out the best modeling approach, and it will build an app. And you can see that the data scientist in this case is able to actually review that plan. I should maybe pause from time to time. What you can see here is that the data scientist is able, is given a plan. Yes, thank you. It's given a plan, and that plan consists of all the steps to go from raw data to a better decision. And that plan contains, in this case, data cleaning. It contains causal discovery, building structural causal model, and figuring out how to use it. So, as you guys would know, figuring out root causes is a very inherently causal problem, and that's why Kaya in this case has decided to use a causal workflow to solve it. But if I was going to choose something else, it may actually choose a different workflow, like a predictive model based on open source algorithms. So Kaya is not restricted to using causality, but in this case, it just makes a lot of sense to do that. what you will see here is that the human data scientist has the ability to actually edit that plan and oops, I think I'm not doing very well with this this pausing part, but what you can see is that the human data scientist has the ability to edit the plan. In this case, they said, hey, I also want to visualize the result. And now we're able to execute kind of the refined plan that differs from kind of the original. And what Kaya will do is we'll go around and write all the code that is required to solve this problem end to end. And so you can see that it wrote some code for data cleaning. And you can see that it's used some kind of open source algorithms to do that. It wrote a plan and code to do causal discovery, and it wrote code to do structural causal modeling. And so this is just a quick kind of overview, and we'll dive into the more specific details in a second. And finally, what you'll see here is that actually it produced artifacts. Artifacts is what we need to operationalize a decision-making agent. So we need to, by putting these things in production, we effectively have an agent. So what Kaya does, it generates the artifacts you need for your decision-making agent. And so as we identified earlier, we cannot blindly rely on automation. We need to have a way to actually develop trust in this whole process. And as you can see here, Kaya is beautifully integrated in our development environment, where you can actually seamlessly see visualizations of all aspects of it. So you can here, for example, see how the data cleaning part was achieved and what does that mean for your, for your data visually. So a data scientist can actually come in and verify that everything that Kaya has done is appropriate. They can look at the code, they can tweak it, they can verify it. So this is one element of bringing trust to this. So remember, we want automation and trust. Only then we can change the world. So this is the data scientists kind of coming in and developing their trust around what Kaya has done. Here we can see how the end user or the business user that will use this is able to provide domain knowledge, which may not be in the data, but also they'll have the opportunity to verify that what Kaya has done makes sense for the real world. So here actually they're providing some knowledge about the manufacturing line that was not in the data. So they're kind of providing the order of causality that may have not been obvious or not available in the data. So what you'll see here is Kaya will take this information and will actually build you a component that shows the flow of causality. So effectively what it says is what's at the top cannot be caused by anything else. What it is in tier 2 can be caused by tier 1 and so on. So it provides for this kind of natural flow of causality. And this way, the user of the algorithm can be certain that the real world is mimicked in the algorithm. So this really helps the human develop, the end user develop trust in what Kaya is doing and what the data science team are doing. And so here they can provide some additional knowledge, and eventually they will get a full causal diagram that will describe the entire manufacturing line. And so Kaya is getting some additional information about the manufacturing process, and will soon be able to produce a causal diagram that will describe everything. So here it is. Kaya has been able to now produce a causal diagram that both the data scientist believes and the end user believes, right? And so this is what we believe a perfect combination of automation and domain knowledge from both the data scientist and the business user in order to get a trusted decision flow. So I don't know if you guys know this, but there was a lot of code that it's so boring for data scientists to write, like transforming that tire component into code. That's really boring code. Kaya was able to write that for you. And so this is kind of the perfect combination of trust and automation in our opinion. We think this is kind of how all AI is going to be built in the future. What you can see here is that once the whole workflow is complete, Kaya is also able to build web applications for you, which is quite cool. So Kaya is not just a data scientist, also, I guess, a UI engineer. So it can actually build workflows. It can build actually applications, and you can see here we're launching the application, and we can now give this to someone on the factory floor. We can now, for the first time, bring AI very rapidly into the hands of someone that may have never actually experienced AI. And you can see here an example of how they would use it. So let me just pause here. This is quite exciting because, so Kaya, together with our data scientists and our domain experts, was able to build this artifact. So a feature transformation pipeline that will work in the real world now. We can give it new data. This will now clean and transform data as it comes live. This is real artifact. It has also built us a causal model that can actually take that pipeline and operationalize it in the real world. And now we can give this to someone on the field in the manufacturing line, and they can actually ask very simple questions in plain English, and they can say, hey, what can I do to prevent faulty items, or keep my manufacturing line up? And they'll be able to get a grounded response in plain English of what they should do. So if they were to increase the humidity of the raw materials, they will be able to, and a bunch of other things, they'll be able to decrease the probability of downtime by 35%. And so this is an example of a grounded LLM in causal understanding of the world that was built automatically by agents, but verified by data scientists and by domain experts, and shipped on the front line to be used by anyone. And these artifacts can now be productized, and now this will work in the real world for new data. And this is what we think is going to be the future of decision making. You can all have your own decision making agent. Thank you very much.
Stay there a minute. So very quickly, if you want to ask questions, please go, as it says there, to Slido. Enter the number 4025787. We're stream 1. So not only can you enter your own questions, you can upvote, downvote other questions there. So the top ones we'll ask. We'll never have time to answer them all because there's too many. But anyway, do go there and you can vote them up and down. Very first one, I'll add a bit to it. What applications will we be trying the agents on first, without giving away any company secrets, please?
Yes. So we're huge believers in kind of thinking about the world currently in two streams. The complex problems, where data scientists are still going to be driving the outcomes, and simpler problems that are repetitive and people like analysts may want to be answering on day-to-day basis. So we see a huge opportunity for creating the initial set of value on automating the simpler things first, giving data scientists the time to actually focus on the hard problems, the things that the agents cannot do. And the simple and the hard problems come from all walks of life, but we are primarily focused on two big areas. One is industrials and figuring out how to make industrial processes more efficient and better. And the second is around customer-related data and helping organizations serve their customers better. So those are the two buckets. Within both buckets, we have very hard problems and problems that can lend themselves to agent automation today.
All right, so thank you, Darko. Another question here. How does Kaya integrate with customers' data store and business logic to leverage the solution in the real world? So basically, how do we get it
Yeah,
working?
absolutely. So actually, Kaya has been also trained on the most common places to get data from. So you remember that treasure trove? Part of that treasure trove is code that we have written to interface with Snowflake, Databricks, BigQuery, and the rest of it. And so Kaya is actually free to use that code and figure out a way to access an SQL database or and almost anything else. So over time, that treasure trove will grow and we'll be able to cover kind of all aspects. But yeah, Kaya can actually write a code to interface with data lakes and can actually search them too. It can actually run algorithms that help people identify the right data set for the given decision-making problem. That's actually, by the way, a huge value add and something that data scientists, may not be too inspired to do, just going and turning stones. AI agents would happily spend a few months or a few days or a few hours looking for the best data set.
Excellent. I'm going to generalize this question. It was asking about ChatGPT, but can you comment on which LLMs we're working with?
Yeah, so we launched a big partnership with Google recently, and we are slightly favoring Gemini currently, just because of that partnership, but we can hot swap almost any LLM. We actually started with GPT. We're currently using Gemini, but it is not a hard-coded dependency. You can actually use an open source LLM too, as long as it meets certain criteria, but it is, the LLM itself is hot swappable.
There are now so many questions, I'm not keeping up, just so you know, which is good. But one of the things I will say, we do have the Causal Lens team here, so if you hold up your badge, it says Causal Lens on it. Yes. If you just look for that, do feel free to engage and ask people outside as well, because there's a few technical questions in here as well that we've got our full team out, including the ones who actually wrote some of this code. So,
exactly. They'll be better placed than me to answer them.
I'll ask, but this may be one that we want to pass on to the team, which is, can Kaya deal with small sample sizes, e.g. when design of experiment is appropriate?
Yeah, so the promise of causal AI is that it's able to figure out how the real world works from a smaller data, right? It's not as data hungry as something like deep learning, and as such, obviously depends. It's not magic, but if you have a reasonable data set of a few hundred data points, Kaya has an edge in causality, and it's able to figure out causal things from data. Therefore, probably your only bet if you have small data set.
This question is more around monitoring the agent, see if it hallucinates or hallucinations are reduced, and security vulnerabilities. So maybe just talk about what we've been doing there from just making sure it does work in the real world.
Absolutely. So as you guys saw in those demos, we don't let the agent out in the field before a couple of things have happened. One, the data scientist has been able to verify that the code that Kaya has written makes sense, and it's fully trusted. The second thing we want to make sure happens is that the domain expert has provided knowledge that is kind of, it cannot be violated by the agent. That's kind of a big deal in what we do versus, just a plain old LLM. The workflow here will always take whatever the human domain expert has said as gospel. It cannot change it. And so by combining the two, by having the data scientist verify the code, and by having the domain expert ensure that the real world is reflected in the artifacts, we're creating a trusted agent. Following that, once we put the agent into production, we have the ability for the end user to get answers and citations that are grounded in the artifacts. So that's kind of the final check. So this is kind of once it's in production, when they use it, they can make sure it's grounded and they get citations of exactly kind of which artifacts produce the insight. So those are the three ways in which we ensure trust into the agentic workflows. So we want automation and trust. We can't do with either of the two. If we want to change the world, we need automation and we need trust. And I think we found the way to achieve just that.
Perfect. Thank you, Darko. Although there's more questions.
I'll be around, guys.
Yeah,
we can chat.
That's Darko.
Yeah.
Thank you.